Good morning, honorable judges. We're from Daye University. I'm the presenter today. My name is Liu Chen. The title of the project is Development of Green Muffler. This project is conducted by Professor Deng, and our team members are Lin Tanxuan, Chen Yongyun, Ye Tingrui, and Liu Chen. Then, the outline. The presentation divided into 5 parts. First, introduction. Second, creation motive. Third, research process. Fourth, brief of work. At last, expected benefits. First, introduction. Muffler. Every car you see on the street has one. It's a necessary part of the vehicle. Muffler is not a performance component. It doesn't help you drive faster or save money on gas. It's a comfort component that people need the muffler to make the driving experience more pleasant for the driver and the people passes by. Then, knowing the principle of the straight-type muffler, the noise of the engine will go from the inlet, and the noise will be absorbed by a series of passage in chambers of glass fiber and released from the outlet. Then, what's wrong with the muffler? Well, we would like to address 2 points of the manufacturing of the muffler. The first point is that in the process of filling glass fiber, the operator needs to wear a mask to avoid breathing in. Second point, it takes too long to complete filling the glass fiber, about 1 minute and 48 seconds. So, is there any material have the same function and require less time? In the project, we compared one of the early experiments. With spiral spoiler in the muffler, the noise can be reduced. The picture of the left is the side of the muffler. The picture of the right is the front view of it. Then, the creation motives. The study said that the floating cement has the characteristic to reduce noise. So we wondered that can we apply on the muffler and reduce the completion time by grounding? The answer is yes. Then the research process. Understand the principle of the floating cement. Mixing the foaming agent and the cement properly can create floating cement. In the mixing process, we compare 2 kinds of mixer, vertical mixer and the horizontal mixer. As the result shows, the horizontal mixer has the better mixing quality, and the results were far more stable. Then, the grounding process. The picture of the left is the empty muffler. The picture of the right is the muffler has been grounded with floating cement. This is the explosion view of it. You can see the structure of the floating cement muffler. Given that density effect on noise reduction, so far the lowest density of floating cement test is 0.2 gram per cubic centimeter. The density of 0.2, 0.4, 0.8 and cement without foaming agent is tested in the chamber of Daye University. The experiment began use a machine to generate a noise for 1 minute, and the noise was connected with the inlet of the muffler, and the microphone is used to receive the sound from the outlet of the muffler. The microphone is connected with the computer, and the Clio software will draw the spectrum diagrams. This is the sample picture of it. The vertical axis is the decibel, and the horizontal axis is the frequency. Then, the brief of work. The muffler modeling is jointly developed with Lianfei Industry and Yong'an Mineral Technology. You can see that there are 4 lines in the chart that represent with the floating cement with density of 0.2, 0.4, 0.8, and ordinary cement. You can see that the green lines represent the floating cement with density of 0.4 is slightly better than the others, but not much. After observed, complete grounding the floating cement only takes 11 seconds. That's 9.8 times of production compared to the conventional muffler. But the drawback is that the floating cement muffler is slightly heavier than the conventional ones. You can see that there are 3 lines in the chart. The red lines represent the spiral swirl improved muffler. The blue lines represent the conventional muffler. The green lines represent the muffler with floating cement with density of 0.4. In the region of the low frequency, you can see that the green line is better than the other two, but not much. After discussing with Yuan Mineral Technology, we came out a hybrid version that added 20 grams of glass fiber in the floating cement with density of 0.4, and the results is far more better. You can see that there are 2 lines in the chart. The blue lines represent the conventional muffler. The green lines represent the muffler with floating cement with density of 0.4 added glass fiber. In the region of low frequency, the green one is lower than the blue one about 20 decibel. In the region of the high frequency, the green one is reduced more than 10 decibels. We used the factorial design experiment to construct a response surface in order to investigate the optimum combination with the density and the weight of the glass fiber. The dependent variable of the response surface is the root mean squares of the decibels. And this is the formula of the root mean squares. You can see that the hypothetical response surface, you can see that there are 6 dots of it. We have already collected 3 red dots, and there are still 3 black dots need to be collected. After we collect them all, we'll know the best combination with the density and the weight to make the green muffler. And this is the top view of it. At last, expected benefit. First point, Daya has been collaborate with Yuan Mineral Technology to develop green muffler and has submitted with patent application, and here is the number of it. The second point, the production rate of the floating cement muffler is 9.8 times faster than the conventional muffler. The third point, the noise level of the floating cement muffler is much smaller than the conventional muffler. In the region of low frequency, it's about 20 decibel is reduced. In the region of the high frequency, it's more than 10 decibels is reduced. The fourth point, if 1% of the world market of muffler will use green muffler, and each muffler's cement costs $300 NT, the gross profit rate is 10%. The gross profit will be 27 million NT dollars per year. Here are the reference. And this is the end for our presentation. Thanks for listening. We welcome any feedbacks.